Next up, we're going to have a very exciting panel with some major thought leaders in the private sector, and then we'll be moving to the incredibly valuable networking time. But I'm just going to spend a few minutes before we move to our panel to kind of, as Secretary Moniz said, we really do find ourselves at the beginning of a truly exciting time, critical time in our nation's energy history, both in terms of clean energy manufacturing, manufacturing those products that are coming down in cost and dramatically coming up in volume, but also in terms of broader trends around our industrial energy competitiveness more broadly. And so, the opportunity we have in front of us in clean energy manufacturing is truly unprecedented. And what I want to spend just a few minutes taking it down another level on the opportunity and how we're responding to it through our DOE Clean Energy Manufacturing Initiative and through AEMC partnership we have with the Council. If you just look at the size of this opportunity, I want to walk you through just a couple of facts and figures. It is estimated that more than $10 trillion will be invested globally in new power generation between now and 2030. This will represent not only rapidly growing demand for advanced manufactured renewable power technologies like wind and solar, but will also give us a tremendous opportunity for the U.S. to export other technologies like advanced gas turbine technologies. I think of that specific example. We're going to have a video showing you some great work that's going on there by General Electric. But I also, when I was in just outside of Beijing not too long ago, just a few months ago, I went to one of the most advanced natural gas combined cycle. It was actually Trigen, making both heat, power, and cooling for an industrial park. When I got to visit this plant, they were very open and transparent, and I asked every question I could think of. And so I asked myself, is there any United States technology in here? And they said, well, yeah, there's a really high-end gas turbine in the combined cycle. And I said, well, about how much of the total value of the plant was in that? And it was 30%. So as China and India and other countries are growing out their energy infrastructure, I think if we get it right, a substantial portion of the value add going into the energy infrastructure, both here and abroad, can come from advanced technology invented and manufactured here in the United States. That turbine was actually manufactured right here in Connecticut. So there's a tremendous global opportunity. In the transportation sector, rapid advances in engine technology, battery technology, power electronics, lightweight materials, along with new fuel economy standards are fueling an innovation and manufacturing boom, a comeback in the American auto industry. And I just point to one example. I think we all saw recently the commitment of Tesla Motors to build a $5 billion battery manufacturing plant right here in the United States in Reno, Nevada. And in the energy efficiency sector, the IEA, International Energy Agency, estimates that globally in the years ahead, more than $300 billion a year will be invested in energy efficiency worldwide, representing a huge and growing global market for manufacturers of advanced energy efficiency products like high-efficiency heat pumps and water heaters, solid-state lighting, variable speed motors, just to name a few of dozens and dozens of examples where we can compete and lead on energy efficiency products. So from the power sector to the transportation sector to the building and industrial sectors, this vast and growing set of markets presents a major opportunity for our nation to leverage its world-class science and innovation into sustained clean energy manufacturing competitiveness. To provide a window into this exciting opportunity, we actually went out with our AEMC partnership and our partners and spent some time with leaders in the advanced lighting industry who are creating clean energy manufacturing jobs all across the country today, from the California Bay Area to North Carolina to Wisconsin and upstate New York. Let's see what they have to say. Cue the video.
There are shots from NASA of the United States at nighttime, and you see these beautiful pictures of the metro areas all lit up at nighttime. What that light is actually wasted light. It is light being reflected into space and not usable. And what LEDs can do is actually drastically reduce that. Philips sees that the lighting revolution is coming through LEDs. So the advantage of U.S. manufacturing is we build an ecostructure of other companies that we associate with, from specialty gases to quartz vendors to suppliers to equipment manufacturers. We spawn innovation and entrepreneurship. It's not only about U.S. jobs in LumaLEDs, it's about U.S. jobs in all these support companies. The U.S. has significant competitive advantages, and we need to keep building on it. We're at a tipping point where we see a lot of the technology maturing, and now the manufacturing has to come in and be able to produce it at a very large scale. And there's a science associated with that, and we need the U.S. government to encourage the development of that science.
LED lighting and solid-state lighting can virtually replace every lighting system there is right now. Roughly 22% of electricity used today is for lighting. So by going to LED lighting, we basically can cut that usage in half or less. The efficiency is higher than any light source right now. The light quality is very good, and the lifetime is better than most any light source now. And the lumens per dollar are coming down very rapidly. So it's very exciting to work at Cree because we're constantly making advances. We make everything from indoor consumer products, street lights, interior lighting. Football stadiums are now going to LED lighting. The potential is to basically replace every light source known to man. DOE funding and companies like Cree help to justify long-term projects that we normally wouldn't otherwise do. So by having the manufacturing here in the U.S. drives the technology to the next level so that we can maintain the leadership in solid-state lighting in the world and continue to grow solid-state lighting in the U.S.
The time to invest in solid-state lighting is now. Solid-state lighting will improve our quality of lives immensely by changing the way we experience light. One of the unique aspects of Soar's technology is the fact that we utilize the advantages of GaN-on-GaN technology, which is higher power density capability and higher efficiency. We're able to actually deliver full spectrum emission for all colors of the rainbow from violet to red. The Department of Energy has done a great job in supporting solid-state lighting in the United States. The U.S. can be very competitive. I don't see any reason why we can't be competitive with overseas manufacturing. It's really a matter of focus and investment. We'd like to keep things in the United States. It allows us to keep a faster paced innovation in environment because of the very strong base of talent. There are big advantages to it in terms of intellectual property, control, and protection. We have a strong base of innovation. We have the best schools in the world. The LED industry has a good opportunity to show what can be done.
Solid-state lighting is at the cusp of a transformation, replacing a 100-year-old incandescent bulb technology. We're beginning to see an increased demand and increased penetration of solid-state lighting. Bottom line, adopting this lighting technology on a mass scale will save billions of dollars to our nation, as well as save millions of metric tons of carbon emission greenhouse gases. And none of this would be possible without the fundamental technology, the MOCVD technology that Veeco manufactures. MOCVD is the first fundamental critical technology step in the manufacturing the LED chip. An advantage of being located in the US is it helps us gain access to numerous high-value supply chain manufacturers. It's really exciting times, and it's really encouraging to see government agencies like DOE really stepping in to bring the industry's partners together to help accelerate the adoption of solid-state lighting in the US as well as globally.
So as you can see in this area of solid-state lighting, as with many others in recent years, we are competing and winning and creating jobs all around this country together. An exciting thing to see. It's happening not just in this area, but many others. But now I want to turn my attention to the other side of the coin, the impact that our broader energy transformation is having for industries across the board. So in addition to the massive opportunity, as we've talked about, for American leadership in the manufacturing of these kind of clean energy technologies, the discovery and production of abundant U.S. natural gas supplies in recent years has strengthened America's energy security, lowered our energy costs relative to the rest of the world, making the U.S. once again a global leader in energy-intensive manufacturing. President Obama said it best recently in Pittsburgh. What we've seen over the last several years is American manufacturing come roaring back. We actually have companies now saying that America is the #1 place to do business again, something that we haven't seen in over 12 years. And companies, instead of outsourcing, are now thinking about insourcing again. We have seen entrepreneurship and manufacturing expand at the fastest pace that we've seen in 20 years. Due to the U.S. shale boom, more than $125 billion in new U.S. manufacturing capital investments have been announced since 2010. And amidst this wealth of resources, manufacturers are also seeing the opportunity and the imperative to implement energy-saving technologies and practices to make them more competitive and bring those savings right to the bottom line. Advancing energy efficiency in the American manufacturing base will take our expected strong position on energy price competitiveness that we expect over the next couple of decades and lock that into competitive advantage that will last for the next 20, 30, 40, or 50 years. At the Department of Energy, we work with U.S. manufacturers who make bold commitments to energy efficiency and see the results in the growth of their bottom line, and the companies that invent and manufacture the technologies that help these industries succeed. We went to a few of these companies so you could see firsthand how and why they do it. Please cue to the video.
Well, Legrand is a small to medium-sized manufacturer. We make electronic products for power, light, and data in the commercial building or residential environment. The reason that focusing on energy efficiency as a manufacturer is important is first and foremost cost. We are challenged every day to provide more value for our customers and to have enough resources to reinvest in the organization and still give a good return. If I'm a manufacturer of clothing or I'm a manufacturer of plastic products, I may or may not have energy connected to what I do, but everything I do depends on energy. And if I don't manage that cost, just like I can manage my raw materials or my labor inputs, then I'm missing a huge opportunity to make me more competitive. The Better Buildings, Better Plant Challenge was to reduce our energy intensity by 25% over 10 years. And that seemed to us a very daunting task. What surprised us was by focusing on it, by engaging the employee base and looking for places that we were missing, and we had a lot of help from the Department of Energy in doing so, we were able to identify and save more than that in a little over 2 years. There was just that much low-hanging fruit because we weren't focused on it. As we were working with our key strategic suppliers, we explained to them what we were doing and how we were doing it, and we challenged them to join us. We were able to get 9 of our biggest and most strategic suppliers to work themselves on their own energy intensity and use some of the best practices and experiences that we had developed. One of the nice things about energy intensity and focusing on reducing it is it's one of those topics that everybody can support. It's not that hard. You don't have to be a technical person. It's not intimidating. It doesn't require huge dollars, and yet you can achieve big impact. I think to keep manufacturing in the United States, we have to optimize everything we do. We have a wonderful economy and a great lifestyle, but we are always challenged to justify that in the form of how competitive we can be.
GE is the premier heavy-duty gas turbine supplier worldwide. We are a U.S. company. We've been a U.S. company for a long time. To get the largest, most efficient gas turbines in the world, the technology is really, really important. But it's not just the science behind the technology, it's also about the delivery of that technology into one of these machines, and that's about manufacturing. The competitive advantage of having our manufacturing facilities connected to our engineering teams is that the pace of advancement of manufacturing technology is a lot faster. We have a long relationship working with the Department of Energy and the National Energy Technology Laboratories. One of our premier combustion technologies that allow us to meet lower and lower emissions is a direct result of working with the DOE on those programs. It's an arms race. Every tenth of efficiency is extremely important. In a high fuel market, U.S. manufacturing benefits tremendously from having the largest, most efficient gas turbines. The technologies that we put into these machines help us win. And when we win, it drives volume. Volume drives investment. Investment drives jobs. And that is the hallmark of what we do.
If that doesn't fire you up, I don't know what's wrong with you. That fires me up. So, now I want to move into just a little bit more detail about our clean energy manufacturing initiative. We launched this a little more than a year and a half ago, and like we said all morning, really 2 sides to it. One, how are we going to be more competitive on the manufacture of clean energy and energy efficient products? On the other side, how do we bolster our energy productivity across all of our manufacturing base to make us a more competitive destination for manufacturing across the board? And so we've really focused on 3 pillars in our partnership with the Council and with Clean Energy Manufacturing Initiative. One, we've committed to significantly increase DOE's advanced manufacturing-focused R&D investments into both clean energy technologies and platform technologies that have broad applicability across clean energy and other industries and industrial efficiency. 2, we've worked on creating a network of shared facilities for manufacturing, research, development, and demonstration. And 3, we've continued to push hard on providing resources for manufacturers to help them enhance their energy efficiency. On the R&D front, this past year, ERE increased its investments into advanced manufacturing-focused research and development to more than $325 million. These investments include millions of dollars for advanced manufacturing research into lightweight carbon fiber, material for vehicles, high-performance energy-efficient windows, advanced biomass conversion technologies, and a wide variety of other cutting-edge technologies. And I'm pleased today to announce 2 new wind manufacturing R&D projects that are just the next step in the drumbeat that we have going forward on advanced manufacturing innovation. One of these projects really represents a distributed new manufacturing technology to enable us to dramatically increase the height of wind turbine towers from on the order of 80 meters we have today up to about 140 meters. We need to do that in order to access more resource. And in fact, going from 80 meters to 140 meters would enable us to open up the whole Southeast as a location of cost-competitive wind power. But it's going to take innovation because you can't move these things very far. So the innovation here is really about distributed manufacturing. And one of the partners we have is a startup spin-out from MIT called Keystone Tower Systems, which is working with a number of advanced companies across the sector of wind manufacturing and deployment on a spiral welding technology where you can actually ship sheet steel and weld it into towers on site. This is the kind of innovation that we're looking to support. And although we've had some twists and turns in U.S. solar PV manufacturing competitiveness, the tide appears to be turning in our favor, with a number of companies recently announcing plans to establish or expand solar manufacturing right here in the United States. Suniva announced an expansion into Michigan. And very excitingly, Solar City and Solevo, both companies with long history with the Department of Energy and the Clean Energy Manufacturing Initiative, have made a commitment to establish over time more than 1 gigawatt of solar PV manufacturing capacity in upstate New York, which would make this one of the single largest solar manufacturing plants in the world. In addition to R&D and innovation, our second pillar is really about facilities, shared infrastructure. And we've gone across the whole country, and we've really begun to create a whole new kind of innovation infrastructure with our partners across all of government for the future of American manufacturing. From Ames, Iowa, to Youngstown, Ohio, to Oak Ridge, Tennessee, and Raleigh, North Carolina, we've established first-of-a-kind centers that focus on foundational manufacturing technologies like critical materials, rare earths, additive manufacturing, carbon fiber production, and next-generation wide bandgap power electronics. Our manufacturing demonstration facility at Oak Ridge, you'll hear more about that from Tom Mason today, the director of Oak Ridge National Lab, has more than 35 3D printers and a 390-foot-long processing line for innovators to try experimental ways to produce carbon fiber at production scales. Our Critical Materials Institute, a $120 million 5-year effort led by Ames National Laboratory. Alex King is here today, can tell you more about this institute, is working to enhance the security of American companies' supply to critical rare earth elements needed for a wide variety of advanced American technologies. More than 17 patent disclosures in just over a year, and they've doubled the number of industry partners over the last year, so we're seeing great success there. And earlier this year, with a $70 million over 5-year investment, we established the first DOE Manufacturing Innovation Institute in support of the President's National Network for Manufacturing Innovation, focused on manufacturing of next-generation wide bandgap power electronics at North Carolina State University. And you'll hear from Randy Woodson, the Chancellor at NCSU, today about that. And we're also looking to announce in the next few months our second DOE Manufacturing Innovation Institute in the area of advanced composites, so stay tuned for that. We're also continuing to push hard in our efforts, you'll hear more about this later today, to really drive our resources to you to help you lower your energy footprint in your factories, from combined heat and power partnerships to industrial assessment centers all across the country that provide free assessments to help you identify the low-hanging fruit in terms of industrial efficiency, and our Better Plants Challenge, an opportunity for you to join a growing network of innovators sharing best practices to meet a bold commitment of 25% reduction in energy intensity of your factories over the next 10 years. We're driving hard in that area. But American Energy and Manufacturing Competitiveness Partnership is not about what we are doing alone at DOE, it's about what we can do together. So I'm committed over the next 2 years, together, we're going to continue to increase our investments in research and development, advanced manufacturing, clean energy manufacturing. We are committed to continue to build out the NNMI infrastructure around the country and continue to work with our national labs to establish world-class manufacturing demonstration kind of capabilities for companies to access. And we're committed to continuing to work with states to help them develop next generation strategies, working with their private sectors and their research infrastructure. We've worked with 8 states to date to help them develop these plans. And over the next year, we want to double down on that commitment and work with twice as many states as we have to date. And last year at this very summit, we launched EERA's National Lab Impact Initiative, an effort to dramatically increase the amount of successful engagement between our national laboratory infrastructure and the private sector. We have already launched an exciting new effort called LabCore, modeled after the NSF's I-Core program, to help pull technology out of the labs, train lab researchers into what the customer wants, the voice of the customer, and try to figure out what technologies they should be working on to be even better partners for you. And over the next year, we're going to open up our labs to technologists and residents, strengthening our partnerships and helping manufacturing companies take advantage of the unique lab capabilities. In addition, over the next year, we'll make $20 million available to small businesses to leverage our national lab resources through a new small business vouchers pilot program. But we can't stop here. We must together commit to take on these challenges in American clean energy manufacturing competitiveness. And through our dialogues and discussion over the last 2 years, this summit, our regional summits, our mini dialogues that we've had a number of you participate in, for me, it's really 3 big themes that we need to rally around going forward. The first is the area of materials acceleration, materials genome. I think there is a once-in-a-generation opportunity for us to dramatically accelerate the rate at which we go from materials discovery to born certified, born qualified parts. Using our high-performance computing infrastructure, advanced computing, advanced modeling simulation, new experimental and diagnostic techniques. The Secretary and I are looking to work going forward with the rest of the department through the Clean Energy Manufacturing Initiative to move aggressively in this direction. Secondly, we need to figure out how to apply Moore's Law not only to that problem, but to clean energy and clean energy manufacturing more broadly. How do we take advantage of unprecedented computing power to transform unprecedented amounts of data into unprecedented and unparalleled insights to make our manufacturing more productive and more efficient? And finally, how are we going to reinvent a model by which ideas are going to go from early stage all the way to widespread deployment? We do not currently have a well-established model. Having been a venture capitalist myself, that model is not appearing to be sustainable. Early stage venture capital in clean energy is down to almost 0. And so how are we going to work together, bringing together philanthropists, foundations, venture capitalists, open innovation programs at big corporate organizations and other entities to really reinvent the model by which we're going to take innovation from the seedling all the way to widespread deployment? And that's an area where I think we pull together, we can do some exciting things over the next year or 2 through our partnership. So these are exciting times, and these are bold goals that we're getting after. But at the Department of Energy, we are committed to action. I'm honored and energized that our colleagues across the department have joined us in the Clean Energy Manufacturing Initiative, and many of them are here today. I want to thank the Council again for being such great partners. I want to thank the Secretary for his leadership, and I want to thank this community of partners for your insights and commitment. Together, we can forge ahead in a winning innovation strategy, and together, we can take on the defining challenges in clean energy manufacturing and seize the unique opportunity before us to cement American leadership in the transition to the global clean energy economy. Thank you very much.